Hello. So our discussion is all about forecasting methods using time series data. So our first forecasting method, that is the naive forecast method or the most recent. Considering this data, let's say this is a data during 2019 from months 1 to 5, that would be from January to May. And then we have the column sales, or these are the actual sales. Actually, these are in thousands. And then we have the forecast column. So since it's most recent, we are going to start with month 2. We will not be able to get the forecast for month 1. It's because we don't have previous data during the year of 2018. So we'll start it with month 2. We will just be going to copy the actual sales, which is 60,000, as our forecast for month 2. So our forecast, that would be 60. Simply, we are just getting the value of our actual sales during month 1, and we are using it as our forecast for month 2. Same is true. So for month 3, our forecast will be 67. For month 4, that would be 72. For month 5, 66. And then for month 6, since we don't have yet the actual sales, we are then going to forecast what would be the sales for month 6. So since we're using still the naive forecast, our forecast then will be 70. So starting from the forecast error, we will be then measuring the forecast accuracy. Later on, we will be going to compare the forecast accuracy among those different forecasting methods that we will be discussed along the way. So the formula for the forecast error will be the actual sales minus the forecast. $67 minus 60, that would be 7. 72 minus 67, that is 5. 66 minus 72, that would be negative 6. And then 70 minus 66, that is 4. If you are going to observe the computed forecast error, your answers could either be a positive or a negative value. MFE stands for mean forecast error, or the average of this forecast error. Get the sum and then divide it by the total number of data. So 7 plus 5 plus 4 minus 6. The total would be 10. 10 divided by 4, that would be 2.50 or 2.5. That is the value of our MFE. Then we proceed with the absolute value of the forecast error. So since it's absolute value, that means that we are just going to get the positive value of our column forecast error. So since 7, 5, and 4 are already positive, we will just be going to copy the values. And then for negative 6, the absolute value for negative 6 is simply 6. And then again, we're going to get the total, that would be 22, or the sum, should I say? The sum is 22. 22 divided by 4, that would be 5.50. So MAE stands for mean absolute error. We proceed then with the squared error. The squared error, or the formula for the squared error, is just simply forecast error squared, or forecast error raised to 2. Simply, we will just going to multiply the forecast error by itself. So 7 times 7, that would be 49. 5 times 5, 25. Negative 6 times negative 6, that would be 36. And 4 times 4, that would be 16. Again, we will be going to get the average or the mean of the squared error. So that would be 49 plus 25 plus 36 plus 16, a total of 126. Divided by 4, that would be 31.50. Okay, we proceed then with the percent error. The formula for the percent error is equal to the value of your forecast error divided by your actual sales times 100. Since we are already getting the percentage, so we multiply it by 100. Okay, so 7 divided by 67 times 100. That would be 10.45%. Same process with the next one. 5 divided by 72 times 100. That would be 6.94%. The next one, we will be having negative 6 divided by 66 times 100. We will be able to get negative 9.09%. And then the next one, that would be 5.71%. And then, for the absolute value of the percentage error, it's again, we will just be going to get the positive value of our percentage error. So that would be 10.45, 6.94, 9.09, and then 5.71. These are all in percent. We get the sum, that would be 32.19%. Or should I say the average? We get the sum and then divide it by 4. 32.19 divided by 4, that would be 8.05%. We proceed with the second forecasting method, which is the moving average forecast. We will be using the same data set that we used during the naive forecast. To get the forecast, we will be getting the average of the last 3 months. Let's say, for example, for month 4, that is the average of 60 plus 67 plus 72 divided by 3, or sales 1 plus sales 2 plus sales 3 divided by 3. That would be 66.33. And then to get the forecast for month 5, that is the average of months 2 to 4. 67 plus 72 plus 66, that is 205, divided by 3, that would be 68.33. And then, for the month 6, that is the average of the last 3 months, which is from month 3 to 5. 72 plus 66 plus 70, that is 208, divided by 3, we will come up with 69.33. Again, the formula for the forecast error, that is your sales minus your forecast. Okay, 66 minus 66.3, that would be negative 0.33. And then, for month 5, that would be 1.67. To get the MFE, we get the sum, and then divide it by 2, which is we get the average. That would be 1.32 divided by 2. That would be 0.67. We then get for the absolute value of the forecast error. This one would be 0.33, and then simply copy 1.67. We get the sum, that would be 2.0 divided by 2. Our mean absolute error, that would be 1.0. Okay, for the squared error, that is the value of the forecast error squared, or raised to 2. So negative 0.33 raised to 2, that would be 0.11. And then 1.67 squared, that would be 2.79. We get the sum, that would be 2.9 divided by 2. We will come up with 1.45. Okay, for the percent error, that is the forecast error divided by the actual sales times 100. That is negative 0.33 divided by 66 times 100, that would be negative 0.5%. And then the next one, that would be 1.67 divided by 70 times 100, that would be 2.39%. We get the absolute value of our percentage error. This would be 0.5% and 2.39%. We get the sum of the two, that is 2.89 divided by 2, that would be 1.45%. The next forecasting method is the exponential smoothing forecast. For the second month forecast, we will be using the naive forecast, or which is the most recent. So for this part, this would be 60 we get the most recent value. Our formula for months 3, our formula for the succeeding months will be the forecast plus the value of your alpha, which is constant. We have it here. That would be 0.4 times the quantity of your actual sales minus your forecast. Let's say, for example, for month 3, that would be our forecast above, that is 60, plus the value of our alpha, that is 0.4, times the quantity of our actual sales, which is 67, minus 60. And then the answer would be, that would be 62.80. So that would be our forecast for month 3, 62.80. Okay, we proceed with month 4. Again, our forecast, that is 62.80 plus our constant value of alpha, 0.4, times the quantity of 72 minus 62.80. The answer will be 66.48. Okay. For month 5, again, same formula. That is 66.48 plus the value of our alpha, 0.4, times the quantity of 66 minus 66.48. We will come up with 66.29. And then same again, for month 6, that would be 66.29 plus alpha, 0.4, times the quantity of 70 minus 66.29. We will come up with 67.77. Again, for the forecast error, we subtract our actual sales minus our forecast. This would be 7. And the next one, 72 minus 62.80, that would be 9.2. 66 minus 66.48, that would be negative 0.48. 70 minus 66.29, that would be 3.71. We get the sum. We will come up with 19.43 divided by 4. That will be 4.86. Okay, again, for the absolute value of the forecast error, simply getting all the positive values. Simply copy 7, 9.2, positive 0.48, and 3.71. We get the sum. That would be 20.39 divided by 4 to get 5.1. For the squared error, simply forecast error squared. 7 times 7, 49. 9.2 squared, that would be 84.64. negative 0.48 squared, that would be 0.23, and then 3.71 squared, that would be 13.76. We get the sum, that would be 147.17 divided by 4. Our MSE will be 36.79. Okay, for the percentage error, that is our forecast error divided by the actual sales times 100. This will be 10.45%, 12%, negative 0.73, and then next one, that would be 5.3%. We get the absolute values of this column: 10.45, 12.78, 0.73, and 5.3. We get the sum, that would be 29.26% divided by 4. Our MAPE will be 7.32%. Okay, since we're already done with computing for the different forecasts using the 3 different methods, we will be then comparing the computed values for the mean forecast error, the mean absolute error, the mean squared error, and the mean absolute percentage error. We will be able to identify which among the 3 forecasting methods is the most accurate forecasting method that for that specific data sets. Okay, for the naive forecast, we got 2.50 for our MFE. For our MAE, that would be 5.50. Our MSE, we got 31.50. And our MAPE, we got 8.05%. For the moving average, we got 0.67, 1.0, 1.45, and 1.45%. For the exponential smoothing, we got 4.86, 5.10, 36.79, and 7.32%. To tell which among the forecasting methods is the most appropriate for that specific data set is through this MAE and the MSE. Okay? The lower the value of our MAE and our MSE, the more accurate our forecasting method will be. So for this given data set, the moving average forecast got the lowest MAE and MSE. So that means that the moving average forecast is the most accurate and appropriate forecasting method for that given data set. And I hope you understand our discussion for today. If you have questions, feel free to contact me or PM me. Thank you.